Assalamu alaikum students. Hope you people are good at your homes. Last time we were talking about a law of conservation of mass. Then we discussed law of definite proportions. During last video lecture, we studied a numerical regarding the law of conservation of mass. Let's discuss some more numericals to make you people understand what actually these laws of chemical combinations are. We have discussed two important laws, that is law of conservation of mass and law of definite proportion, also called as law of constant compulsion. So today's video lecture is wholly or solely based upon two numericals. We will discuss two numericals in this video lecture so as to make you people understand the basic nitty-gritty, rather the bottom line of these laws of chemical combinations. So let's discuss, students. We have a numerical: hydrogen and oxygen combine. Hydrogen and oxygen. Whenever I talk about this hydrogen and oxygen, that means they are reactants, because starting materials are called as reactants. That means they are reactants. Combine in the ratio of 1:8. The ratio here is 1:8. You must remember that in the last video lecture when we studied law of definite proportions, during the law of definite proportions, I told you people that whenever there is a formation of a water, whenever there is a formation of a water molecule, this is this H2O. Whenever there is a formation of a water molecule, there should be the ratio should be the 1:8. That means 1 gram of oxygen should react with 8 grams of oxygen, then water will get formed. And I told you people that whatever may be the source from which a compound is obtained, it is always made up of same elements in the same proportion by mass. That was in accordance with the law of definite proportion. So I told you people that whenever there is a formation of a water molecule, a compound molecule, there is always formation, there is always a ratio 1:8. That means 1 part of hydrogen and 8 parts of the oxygen. Whenever they react with each other, whenever they combine with each other, there is always the formation of a water. And I told you people that whatever may be the source from which you people are getting this water, like pond water, well water, river water, sea water, the ratio will remain same. Same is the case with this. Hydrogen and oxygen combine in the ratio of 1:8. That means this line is in accordance with law of definite proportions. So to form water means H2 plus O2 when reacts, this forms water, and they combine in the ratio of hydrogen 1 part and oxygen 8 part. That's why here is 1:8 parts by mass to form water. What weight of oxygen gas would be required to completely react with 6 grams of hydrogen gas? The question demands here that what weight of, mark my words, what weight of oxygen gas would be required to completely react with 6 grams of hydrogen gas? Means that how many grams of oxygen would be required to completely react with 6 grams of hydrogen gas. So the solution of the question is ratio in which hydrogen and oxygen combine. That ratio is 1:8. Jot down this fast. The ratio in which, here the ratio, hydrogen and oxygen combine in the ratio of 1. That means ratio in which hydrogen and oxygen combines, that is 1:8. This is definite ratio. So that means 1 gram of hydrogen combines with 8 grams. The question demands here that 1 gram, this is 1 gram 1 gram of hydrogen. So ratio, that means ratio in which hydrogen and oxygen combines, that is 1:8. The ratio in which the hydrogen and oxygen combines, that is 1:8. Now that means, mark my words and jot down, that means 1 gram of hydrogen combines with 8 grams of oxygen. This is given in the question that whenever there is a reaction between hydrogen and oxygen combine in the ratio of 1:8. That is, 1 part of hydrogen reacts with 8 parts of oxygen, then water gets formed. So 1 gram of hydrogen combines with 8 grams of oxygen. Now the question here asks us that what weight of oxygen gas would be required to completely react with 6 grams of hydrogen gas. So this is quite simple, I mean to say. 1 gram of hydrogen combines with 8 grams of oxygen. Now if I will tell you that 6 grams of hydrogen will combine with, that is 6 grams of hydrogen will combine with oxygen, that is 6 into 8, that is 48 grams. Is the answer, right answer is 48 grams. We were asking that what weight of oxygen gas, O2 gas, would be required to completely react with 6 grams of hydrogen gas. In the question that we have given data, we have 1 gram of hydrogen reacts with 8 grams of oxygen to form water molecule. Now the question demands here that what weight of oxygen gas would be required to completely react with 6 grams of. I told you people that 1 gram of hydrogen combines with 8 grams of oxygen to form water. So 6 grams of hydrogen reacts with 6 into 8 because the ratio will not get changed. I told you people this numerical is in accordance with law of definite proportions. According to the law of definite proportions, in a pure chemical substance, the elements are always present in definite proportions by mass, or I mean say whatever may be the source from which a compound is obtained, it's always made up of same elements in the same proportion by mass. So what weight of oxygen gas would be required? That means 6 grams of hydrogen gas reacts with 8 grams of oxygen to form water. That means what weight of oxygen gas would be required to completely react with 6 grams of hydrogen gas? That means 6 into 8, that means 48 grams of oxygen gas would be required to completely react with 6 grams of hydrogen gas. So the right answer here is 48. So this was first numerical. Now let's move to another numerical. So the second numerical is when 3.0 grams of carbon is burnt in 8 grams of oxygen. That means when we burn carbon, this is carbon, that means 3 grams of carbon is burnt in presence of 8 grams of oxygen. 8 grams of oxygen, that means here's the formation of a carbon dioxide gas, that is 11 grams. The ratio is 3:8. In the last video lecture, I told you people that whenever there is a formation of a carbon dioxide gas, whenever there is a formation, look, whenever there is a formation of a carbon dioxide gas, the ratio is always 3:8. I discussed with you people three processes. I told you whenever we burn coal in presence of oxygen, carbon dioxide gas is formed, but the ratio always remains same. That's 3:8. That means 3 parts of the carbon reacts with 8 parts of the oxygen. Then carbon dioxide will get formed. And I told you people that whenever we heat limestone, calcium carbonate, the moment we heat this calcium carbonate, there is always the formation of a carbon dioxide gas. But this carbon dioxide gas is having the same ratio, that is 3:8. That's why I told you people this is in accordance with the law of definite proportions. So same is the case with this numerical. When 3.0 grams of 3 grams of carbon is burnt in 8 grams of oxygen, 11 grams of carbon dioxide gas is formed. What mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen? Which law of chemical combination? What mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen? Which law of chemical combination will govern your answer? Look, firstly, carbon plus oxygen reactors form carbon dioxide. The answer of this question is whenever the carbon reacts with oxygen, because the work of the oxygen here is that it helps in burn. It helps in burning. It helps in burning. Mark my words, students, and jot it down. Carbon plus oxygen gives carbon dioxide, means it helps in, oxygen helps in burning. So the question tells us that 3 grams of carbon plus 8 grams of oxygen reacts and they forms 11 grams of carbon dioxide. This is given in the question that 3 grams of carbon reacts with 8 grams of oxygen to form 11 grams of carbon dioxide. That means now the question demands here that what mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen. This means that if 50 grams of oxygen is there, but I told you people that the ratio is 3:8. That means this ratio is in accordance with the law of definite proportion. So the ratio will remain same. That's 3:8. That means if there is 50 grams of oxygen, there only 8 grams of oxygen will react, because the ratio will remain same, because this is in accordance with the law of definite proportions. Whatever may be the source, whatever may be the process, the ratio will remain always same. That's why I told you that out of 50 grams of oxygen, there will react only 8 grams with 3 grams of carbon. That means 50 minus 8 equal to 42 grams. 42 grams of oxygen will remain unreacted. That means 42 grams of oxygen will remain unreacted. 42 grams will no longer react with carbon, because the ratio should remain 3:8. Because whenever there is a formation of a carbon dioxide gas, the ratio should be 3:8. That's why I told you people that out of 50 grams, the question here tells us that what mass of carbon dioxide ratio will remain same. That means out of these 50 grams, because this is in accordance with law of definite proportion, that means 3:8 ratio means I told you people that whenever there is a formation of a carbon dioxide gas, the ratio remains same. That's 3:8. Here also the carbon dioxide gas is formed, but out of 50 grams of oxygen, only 50 grams of oxygen, only 8 grams reacts with this carbon to form carbon dioxide, and 42 out of 42 grams remain unreacted. That means that these 42 grams will not react with carbon because the ratio should 3:8 out of, so this numerical is in accordance. Which law of chemical combination will govern your answer? That is, this law is, I can say, with respect to the law of definite proportion. That means this is based on the law of constant composition, because the composition should be same, that is 3:8. So these was some of the numericals regarding the law of definite proportions. In the next video lecture, we are going to discuss some more numericals to make you people understand what actually these laws are. Till then, Allah Hafiz, stay safe and stay blessed.